Okay, boys and girls, today we are going to be practicing simplifying fractions. There are two different I can statements for this. There is I can simplify fractions using the greatest common factor, or I can simplify fractions by converting improper fractions to mixed numbers. So we're going to review and go over both of those strategies today. So my first fraction that I am going to model is 3/12. Okay, we are going to simplify 3/12 by again finding the greatest common factor. So the first thing we need to do to find the greatest common factor is to make a factor rainbow for 3, our numerator, and a factor rainbow for 12, our denominator. So the factor rainbow for 3 is 1 times 3, and that's all. And then 12, 1 times 12, 2 times 6, and 3 times 4. Then we have to find our greatest common factor, which it says right here in our I can statement. So our greatest common factor is 3. And the final step we have now is we take that greatest common factor and we divide both the numerator and the denominator by the greatest common factor. Remember that simple tip that we talked about in class? If we can't remember the division part, go back to your rainbow. So we start with our 3 rainbow, and what's connected to the 3? A 1. Then we go to our 12 rainbow, find our 3, what's connected to it? A 4. So 3/12 in simplest form is 1/4. Let's try another one. Let's do 10/15. Okay, again, factor rainbow, 1 to, oops, sorry, not 5. 1 to 10, 2 times 5, okay, and then down to 15. 1 times 15, and 3 times 5. Our greatest common factor, or GCF, is 5. And then we come back to our fraction and we divide by the GCF. So we go to our 10 rainbow, find our 5. What's it connected to? It's connected to the 2. We go to our 15 rainbow, find the 5. What's it connected to? The 3. So 10/15 in simplest form is 2/3. Now, the other way that we can simplify fractions is if we have an improper fraction. And remember, an improper fraction is a fraction that has the numerator larger than the denominator. 11/8. So since our numerator is larger than our denominator, we know that we have more than one whole thing. And in order to solve this, we have to do our fraction as a division statement. So we have 11 on the inside and 8 on the outside. And if you have a problem remembering that, remember we drew our little cowboy, and this was his horse. Okay. Remember, the cowboy lives inside the house. That's where the 11 goes on the inside of the division problem. And the horse, which would be the 8, stays outside the house. He doesn't go in the house. So we have 11 divided by 8. So if we listed our multiples, 8, 16, and we can stop there. How many times does 11 go into 8? I'm sorry, 8 go into 11. It's 1 time. 1 times 8 is 8. We subtract. 11 minus 8 is 3. So now in a normal division problem we would have had a remainder, but in this case we need to convert it to a mixed number. So our mixed number, we first start with our quotient, which is 1 whole. So we've got our 1 whole. How many pieces do we have left over? That's our remainder, which is 3. And our denominator of 8 stays the same because we still have 8 pieces. So 11/8 in simplest form is 1 3/8. Let's try another one. Okay, let's try 13/9. Okay, again, the 13, the numerator, goes on the inside, the 9 goes on the outside. If we come over here and list our multiples, oh, we can already stop. 9 goes into 13 only one time. 1 times 9 is 9. 13 minus 9 is 4. So then we come over here, our quotient, which is 1 whole. What's left over? 4 pieces out of our 9 pieces. So 13/9 in simplest form is 1 4/9.